Fly me to the moon and let me play.
We're off to the moon this morning here on BBC Radio Cambridgeshire,
Let me see
as we speak to a local company who have designed equipment heading into outer space later this week. They're called Thermoteknix, and Dr. Richard Salisbury is the company's managing director. Morning to you, Richard. Good to have you on the show.
Good morning.
So you're off to the moon, or your equipment rather is off to the moon. What is it? What sort of equipment are we talking about?
We're talking about thermal imaging cameras, and they'll be launched on Thursday from Cape Canaveral on an Atlas V rocket, and it's all part of a project to explore the moon for subsurface water.
Okay, is this something you've been involved in before, or is this the first for you and your company?
No, we've actually put infrared cameras on rockets in the past, and it's because of that that we've got space-certified cameras that we was chosen as a UK company to put our equipment onto an American rocket.
Okay, so what does the equipment look like?
It's a very small camera, about 4 inches by 2 inches, that weighs 60 grams, and it's a high-resolution thermal imaging camera that will be used to record the dust cloud as the first of the two rockets impacts into the moon's surface.
Impacts into the moon's surface? That doesn't sound like a soft landing.
Well, absolutely not. It's designed to make a large hole and to throw up a dust cloud, and in the dust cloud, which will hopefully contain subsurface water, we'll be looking at the particles as they come up from the surface of the moon, and then there'll be other instruments that'll be recording the spectra as the cloud goes higher into space, about 30 or 40 miles up from the surface.
Okay, so whose job is it to protect your camera when it smashes into the face of the moon? Is that NASA, is it?
The intention is it'll be smashed. What's going to happen is that the Atlas rocket will take a trajectory around the moon. It'll be about 6 to 7 weeks while it gets into position over the South Pole, where there's a dark crater that's permanently in the shadow, where they expect that there may be water. It'll then release the first of the trajectories, which will come out of the top section of the rocket, and that will go directly into the moon's surface and make a large hole. And we'll be following about 4 minutes later, recording all of the events as they happen, and then we too will impact into the moon, and that'll be a one-shot deal for our camera.
Oh, so it better be working then. Is there a bit of pressure here, Richard?
There is an element of pressure, but we have done this before, and we have had 100% success rate with other similar sorts of projects.
When you say you've done it before, with the moon or
not with
what?
the moon? We were part of an American defence project which is called Aegis, which you may have heard about in the past, which is designed to protect the Earth against incoming ballistic missiles, and we've been used as a targeting sensor where we have been used as part of the guidance system to identify incoming missiles. So we have had proven space experience with our cameras.
How big is this hole when it impacts on the face of the moon?
It's going to be about 20 metres in diameter and go down to a depth of about 5 metres, so about 70 feet wide and 15 feet deep.
Are they anticipating finding water in this cloud of particles which will erupt when it hits the surface?
They're very hopeful. This all started 10 years ago. There was a project which was a moon exploration project, where at the end of the project, the targeting spacecraft, at the end of its observation, impacted into the moon, and they were hoping that they'd get a similar sort of dust cloud that would come out of it. But unfortunately, it went in at a rather oblique angle, and it just grazed the surface. And so this whole project has been designed so that the trajectory, which is actually the empty fuel cell from the rocket, will go vertically directly into the moon's surface.
Do you know anything about the moon, or is it just the equipment which just has lots of varied applications? Have you had to learn about the moon, or is that something you knew about already?
Our camera, Thermoteknix, specialises in making infrared cameras, and we do that for a variety of applications. So these range from putting them on Formula 1 race cars, Indycars, putting them onto cameras that are used for fever screening, which is the hot topic at the moment. We make cameras that are used for screening people as they go in and out of airports to make sure that they don't have H1N1 flu virus, which you were talking about earlier this morning. Also for looking for heat loss in buildings, industrial applications, scientific applications. It's really very widespread, the technology.
So when they said we want to find water on the moon, it was sure, fine, we've got the camera for the job?
Absolutely right. We've got proven technology, and that's a field that we're well known in, is in thermal imaging, and it's nice that a local Cambridge company design and manufacture all of our infrared cameras here in Cambridge.
So can it pick out, just to return to the swine flu you mentioned, which airports is it working in, your camera?
We've got them in 4 airports in Thailand, some other airports in Asia, and we've just supplied systems to Mauritius, where they're concerned that tourists arriving at the airport may be coming with fevers, and so they've set it up as a fever screening system to screen all passengers as they arrive into immigration in Mauritius.
So it can detect just changes in temperature, in body temperature, and can pick out those people who are suffering from a fever and those who are healthy, then?
That's the intention. It's a broad spectrum screening system. It's relatively inaccurate, but it will identify people whose body temperature is above about 38 degrees C. And as a mass screening system, it's very good because it will primarily screen people who've got a fever, and then they're taken on one side, and then they measure their oral or ear temperatures as a result of it.
But if you're a lady having a hot flush, could you get pulled over?
Could be. Okay. Unlikely, but it could be. Could happen.
Well, when's countdown for the rocket launch?
Countdown's on Thursday, and it should be shown both on the internet and also live on the Discovery Channel.
Oh, wow. And when does your part of the operation happen?
Not until October. It takes about 2.5 months for them to manoeuvre it into position, and it goes around several orbits, and then when it's in position in October, then our bit comes into play.
Okay, well, I hope you don't have too many sleepless nights. And how does the information get back to base?
It's relayed up to the Atlas rocket, which continues in orbit and will continue for months after that. And there's telemetry, so that all the pictures are relayed live back to the Earth.
All right, fascinating. All the best, Richard. Good luck.
Thank you very much.
I'm nervous for you.
Thank you very much indeed.
Take care. 8:47. That's Dr. Richard Salisbury, who's managing director of the Cambridge-based company Thermoteknix. It's 8:47.
BBC Radio Cambridge.